Hey guys, these are our notes for Unit 3, Lesson 1.2. Make sure your name is on your new digital notebook. You can fill in your table of contents. Today we're going to be talking about reference angles and coordinates. So at the top of your paper, you can go ahead and title it Notes 3.1.2, if I can find my highlighter. Reference angles and coordinates. You don't have to write down the essential question, but at the end we want to be able to describe how to sketch an angle in the unit circle. We want to be able to answer how do you find the reference angle and how can you determine the coordinates on a unit circle. Okay, so first off, let's draw a little unit circle. Okay, so a unit circle is a circle centered at the origin with radius of 1. So the way that you would draw it is first you're going to draw your x and y axes, you're going to plot your center at the origin, then you're just going to go up 1, right 1, down 1, left 1, and that's your unit circle. When we draw angles into the unit circle, the way that it works is you always start on the positive y-axis. We consider this like 0 radians. This side right here from the center to the point 1, 0, this is your initial side. And then, so going around the unit circle, this would be pi radians. All the way around the circle would be 2 pi radians. So wherever your angle stops, I'm just going to put it somewhere over here in the second quadrant. This angle right here, right? The side where it stops, they call this the terminal side. So on a unit circle, we always start with our initial side right there on the positive x-axis, and then the initial side will just be, wherever the angle would end, and call that the terminal side. All right, let's talk about a reference angle. So reference angles are acute angles that are made with the x-axis. So depending on which quadrant you're in, it will change how you find your reference angle. So really quickly, go ahead and sketch your unit circle. You draw your x and y axis, put your center in the middle, go up 1, right 1, down 1, left 1, and then connect them to form a circle. The way that it works is if you are in quadrant 1, okay, if you're in quadrant 1, the reference angle is the same as the angle. I'm just going to write reference angle. If you're in quadrant 2, so say you have an angle here, that's already an acute angle, okay? That's already an acute angle. If you're in a quadrant 2, this angle is an obtuse angle. So your reference angle is actually the angle that would make 180 degrees or would make pi radians. So all you have to do is find out how much angle it would take to get to the x-axis. If you were in quadrant 3, that's a very big obtuse angle, it's over 180 degrees. Your reference angle is just going to be how much you went over the x-axis. And finally, if you were in quadrant 4, that would be a really big angle, right? Your reference angle is always acute, so it can't be that big. It's just how much angle to complete the circle. All right, last thing for our notes before we do our examples. Let's see. The last thing we're going to talk about is the coordinates. So coordinates on a unit circle. So the XY coordinates on the unit circle, okay, this point right here on the unit circle, any point on the unit circle can be found using cosine of the angle, comma, sine of the angle. So whatever this angle is that you formed, the coordinates of this point right here is going to be the cosine of your angle, comma, sine of your angle. So the one thing that you need to know though is that your calculator needs to be in radian mode. All right, let's go ahead and do some practice problems. So I believe that this should be hopefully on page 19 of your workbook for our examples. So example 1 says on a unit circle, sketch angles that measure 2 pi over 3 radians, pi over 4 radian, and 9 pi over 7 radians. So the first thing you want to do is sketch a unit circle. I don't know if your 2, 3, 4, 5 might be at the top of your page, so you might have to draw your unit circle at the bottom. I'm actually going to do 3 separate unit circles for each one. So each one I'm going to do its own little unit circle. So when I draw my unit circle, I actually, it's supposed to be your X and Y axis, right? I'm only going to draw my my X axis actually though, and then I'm just going to draw my unit circle pretending that that Y axis is there. Okay, so you put your center and then you go up 1, right 1, left 1, down 1, and I draw my little unit circle. And I label it. Here's 0, pi, 2 pi, because we're in radians. That's 0, 180 degrees, 360 degrees. And then I'm going to go ahead and sketch 2 pi over 3 radians. Okay, so the way that you sketch it is you're going to cut your slices of pi with whatever number's on the bottom. And then the top is how many you want for your angle. Okay, we're only cutting top because it's 2 pi divided by 3. So it's, we're just going to look at the top as our pi. So we're pretending we don't have the 2. It says pi divided by 3. That means we're going to cut 3 pi slices, and then we want 2 of them. So pi is only the top half. I'm only going to cut the top half, and I'm going to cut it into 3, as best as I can, equal pieces. Okay, so I cut it into 1, 2, 3 pieces. How many pieces I want, though, is I want 2 of them. So my angle is going to be this angle right here. So let me maybe do like another color or something. So my angle would be, here's my initial side, and I only want 1, 2 of the slices. So this would be my terminal side, and this right here would be my angle. So you might want to like highlight, use a different color or something, but this piece is my angle, 2 pi over 3. Let's try it again so you guys kind of get the gist of it. So I'm not going to draw the y-axis, I'm only going to draw the x-axis. I'm going to draw my center, and I'm going to go up 1, right 1, down 1, left 1, connect those to make my circle. And then whatever number's on the bottom, right, that's how many pieces I'm going to cut. So I'm going to cut it into 4. And then I only want 1. So for pi over 4, I'm going to cut pi into 4 slices, and then I only want 1. So when I cut it, I'm going to cut it into 4 slices so I can cut it in half, then each half into half, and then I only want 1 slice. So here's my 4 cuts, but I only want 1. So here's my initial side, and then I'm going to have my terminal side. It's just after the 1. Okay. All right, last one, we're going to do 9 pi divided by 7. So I'm going to draw my unit circle. Wasn't a very good one, but what I'm going to do is I'm going to cut it into 7 slices, and then for my angle I'm going to use 9. So here's my 0, pi, 2 pi, I'm going to cut it into 7 slices on top. So try to make them as even as you can. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. I want 9 of them though. So here's my initial side. Well, I only have 7 up here. So how do I get 9? Well, I'm going to have to cut the other pie, the bottom half, into 7 slices as well. 1, 2, 3, 4, 5, 6, 7. So now I have 8, 9, 10, 11, 12, 13, 14 slices, and I want 9 of them. So this will be my terminal side. So this is a nice big angle over 180 degrees in quadrant 3. Okay, so that's how we draw them. You cut slices, whatever the bottom number is, and you want however many are on the top. Let's do some reference angles now. So reference angles, we want to find the reference angles for 11 pi over 9, 3 pi over 5, and 5.895. Okay, so I'm going to draw my unit circle. So I'm going to go up, down, right, left, and I'm going to draw my first angle, which is 11 pi, so that's how many I'm going to cut. And this is how many for my angle. So I'm going to cut it into 9 slices on top, so that's not very easy. 1, 2, 3, 4, 5. Here's 9 on top, but I want 11, so that means I'm going to have to cut 9 more on the bottom. So I want 11, so I have 9 on top, and then I want 2 more, so that's going to be my angle right here. That's 11 slices. So my reference angle, okay, so your reference angle, if you're in quadrant 3, if you remember from our notes back here, if you're in quadrant 3, your reference angle is just how much angle you went over the x-axis, right? So how many pie slices did I go over? I went over by 2 slices. So then our angle would be 2 pi divided by 9, because that's how many that bottom half is cut into. So my reference angle is just how many slices I went over. So it's 2 pi divided by 9, because that's how many slices I had cut it pi into. All right, let's do our next one, 3 pi over 5. So I'm going to draw my x-axis. Here's 0 pi, 2 pi. I'm going to go ahead and cut it into 5, and then for my angle I want 3, so I'm going to cut the top into 5, and I want 3. So here's my initial side. I'm going to go 1, 2, 3, so here it is. So this means I'm right here in quadrant 2, right? I'm in quadrant 2. So in quadrant 2, your reference angle is how much angle to get to the x-axis. So how much would be left to complete half of my circle. So for this one, how much I have left would just be 2 slices again. So 2 slices left. So then it would be 2 pi divided by, well, how many slices did I cut pi into? I cut it into 5 slices, so it matches whatever the original denominator was. All right, our last one is in decimals. So when we do our unit circle, instead of 0 pi, 2 pi, this would be 0, 3.14, that's our approximation of pi, and 6.28. I'm also going to label 90, which half of 3.14 is 1.57 radians, and 270 degrees would be 4.71 radians. I just added 6.2 plus 3.14 and cut it in half. Okay, so we want 5.895 radians. So here's 4.71, here's 6.28. So then 5.89 would be somewhere over here in quadrant 4. So it's this huge angle right here. Well, let me do it in blue. So it'd be this huge angle right here. Well, if you're in quadrant 4, okay, if you're in quadrant 4, the way that you find it is it's how much angle to complete the circle. So to complete the circle would be 6.28. So we're going to do 6.28 minus the 5.895. And that's going to give us, let's see, it's just 0.385. All right, 2 more examples. Number 3 says use the following diagram of an angle in a unit circle to demonstrate the point of the side represents cosine, comma, sine. Okay, so what you need to do is we need to label our pieces. This is angle theta, so this is opposite. This is your adjacent, and this is your hypotenuse. So if we wanted to find this side over here, right, this side, we would have, before I move on, actually, the hypotenuse is something we actually know. Since this is the unit circle, the radius is equal to 1, so we know that one. So if I wanted to find the opposite side, I would have to use sine, because sine of theta is equal to opposite over hypotenuse. But we know the hypotenuse. The hypotenuse is 1. So sine of theta is equal to the opposite side. So I'm going to label this as sine of theta. Then if I wanted to find the adjacent, well, adjacent uses cosine, so I'm going to use cosine of theta equals adjacent over hypotenuse. But we know the hypotenuse. The hypotenuse is 1, so cosine of theta is equal to adjacent. So this adjacent side is cosine of our angle. Well, when you get to this point right here, to get to this point, you have to go right and then up. So the coordinates of how you go right and then up would be, I went right cosine of whatever my angle was, comma, up whatever the sine of my angle was, because right is your x, up is your y. We're going to use this fact right now in our last problem. Find the coordinates of the point where the terminal side intersects the unit circle, round each coordinate to the nearest hundredth. So we want to find the coordinates of this point right here. Okay, that's our goal. We want to find the coordinates of this point. Well, in order to do that, we're just going to do cosine of our angle, 6 pi over 7, comma, sine of our angle, 6 pi over 7. And one thing that you have to make sure is that your calculator is in radian mode. Whenever you use sine or cosine, whatever you're taking sine or cosine of, you have to look if it's in degrees or radians. If it's degrees, it'll have that little degree symbol. If it's in radians, it usually has a pi, or it'll say radians. So cosine of 6 pi over 7. So I want to make sure I'm in radian mode. So radians is degrees. So cosine of 6 pi, we have to use a pi button. So it's negative 0.90. It said round to the nearest hundredth, which is 2 decimal places. So negative 0.90, comma, and then the sine of 6 pi over 7. And we get 2 decimal places will be 0.43 will stay. All right, and that's our answer. All you have to do. So I think your last 3-ish homework problems are just like that. You just have to type them into your calculator, cosine of the angle, comma, sine of the angle. The notes part that we took goes on slide 9. Page 19 notes goes on slide 9 as well. Then page 20 goes on slide 10 and page 21 as well. And then your homework, I think, is on page 25. Okay, thanks.